go. 3.2C notes special case factoring. Okay. These are situations where there's a pattern or a rule that we're following. Okay. So it's not like a whole lot of guessing and checking and making. It's a pattern and a rule that we are following. Got it? All right. So up first, we have method number 6, which is difference of two squares. Okay. With methods, I want to remind you, you have to look at the problem to decide which method to apply. Okay. Method. Okay. But here we go. Difference of two squares, or dots, I like to call it. Okay. So here we go. We have a squared minus 1. If we have a squared minus 1, that means we're missing our b term. Agreed? Do we see that there's no b term? So our b term would just be 0x. Does that make sense? Yeah. If there's nothing there, then for addition, it's 0. Agreed? Yes. So mentally, you're asking yourself what multiplies to equal a times 1 times negative. I don't know why these are supposed to be A's, not X's. I don't know, guys. I don't know if I wanted to work with A's or X's. I have no clue what I was doing. A's. We're just gonna make them A's. Who knows? Who knows? This is what happens when you're making notes at like 1 a.m. Okay. Don't worry. I'm here. Multiply. So what multiplies to give us -1, but adds to give us 0. Okay. And what would that have to be? 1 negative. A 1 and a -1, right? It has to be something that's going to cancel itself out. Does that make sense? So that's why our factors would be a minus 1 and a plus 1. Wait, can we agree? Yeah, you can switch whatever you want. Okay. I just need it to be consistent up here. All right. So with that same logic, if I have 9b squared minus 4, right? That means I'm missing my b term. My b therefore equals what? What's missing? That 0b, right? That 0. But I'm still asking myself what multiplies to give me a times c, which is that's plus 0b. 36b squared. 36b squared, right? But I need to add to give me 0, right? So what makes -36b squared but adds to give me 0? Say that again. Say that again. No, you keep saying -36 and positive 36. It's a 6 and a 6. Oh. Yeah. Why is it not 6 and -6? Yes. That just makes 0, but -36 times positive 36 is not 36. Wait, so it's -6 plus -6. Wait. So it has to be -6b and positive 6b. Agree? We see now? I don't like to see why we're doing it, but like it's because we're on a new problem. That's what the variable is. That's the variable. Yeah. It's just a variable. X can be anything. No, but I'm saying why did this switch for A to B? Because she wanted 1 second. No, oh yeah. Yeah. Oh, they're 2 different problems. Yes, we're on problem 2. 9b squared minus 4. Okay, I was actually doing so good. Wait, 9 times 4, and then that's how we got 36, right? Yes. Okay, so in here I have 9b squared. I have -4, and the b's that worked were -6b and positive 6b. Okay, greatest common factor of my first row. 3b. Greatest common factor of my second row. -2. Greatest common factor of my column. Greatest common factor of my last column. It's a positive 2. Okay, so when you're done, your factors are 3b minus 2 and 3b plus 2. Look. So on the negative, you turn that to a plus OB? Because there's no b there. We didn't turn it. We inserted. So why did we turn it? Why can't we just put negative? You can. Does it matter if 0 is negative or positive? Oh. I was like, oh, okay. All right. So now, after doing this over and over, someone came to a conclusion of what they were doing. They were like, oh, wait, guys, does anyone see a pattern or a connection between example 1 and example 2? Raise your hand and I'll call. Hit it, George. What's your... Okay, your first term and your second term are the same, except it's being added and subtracted. Why do you think that is? Show of hands. Okay, because we have to cancel out the equal 0. Otherwise, if they're different numbers, are they going to ever equal 0? No. Okay, there are only certain numbers that this works for. So if you look at 9 and 4, what kind of numbers are those? 9 and 4? They're perfect squares, right? 9 and 4 are perfect squares. Hence why this is called difference of two squares. Okay, it has to be a situation, guys. It has to be a situation where you have perfect squares and you're subtracting them. Okay, otherwise this rule doesn't apply. Does that make sense?
Yeah.
Okay, so we're gonna do some out loud practice. You're not writing anything down until it's your turn to practice independently. Okay, we're gonna do out loud practice. Are we ready? All right, so that means all eyes on the board, pencils down, brains open. Okay, first, x squared and 9, are those perfect squares? Yes. So what is the square root of x squared? What is the square root of 9? What would my factors be then? There we go.
Wait, can you write this down on paper?
I don't want you to write anything down. Write nothing down. You are out loud practicing right now. Okay? I want you to see that this is a pattern and it's a pattern that you can catch on to. Got it? Here we go. Example B. Here we go. X squared minus 25. Is x squared a perfect square? Yes. Is 25 perfect? Yes. Am I subtracting? Yes. What is my factor? There we go. All right. C. Here we go. Are both perfect squares? Are they being subtracted? What is my factor? There we go. Okay. All right. D. Are they both perfect squares? Are they being subtracted? What are my factors?
Oh, 2A and 3.
2A and 3.
What the heck?
So I thought I had both of them.
No. That's GCS.
Wait, okay, so what is this called that we're doing right now?
Difference of two squares. What's written on your or factors. Yeah. Okay. All right. Ready again? Are they both perfect squares on E?
Yeah.
Are they being subtracted? All right. What are my factors? There we go. Trust the process. All right. F. Are they both perfect squares?
Yeah.
Are they being subtracted?
No.
So guess what? I cannot apply this because are they being subtracted?
No.
No, they're not. Do they have anything in common? No. So this is prime. Yes. All right, here we go. G. Are they both perfect squares?
Yeah.
Are they being subtracted?
Yeah.
What are my factors? Minus what? And
And then 6 is minus.
No, it's plus.
because they have to cancel out to make what? 0. All right. Let's get a little tricky.
Oh,
They had to add.
Are they both fractions? Oh, yes, not fractions.
No.
Are they both are they both perfect squares?
Yeah, kind of.
Yes, they actually are. Okay. Are they being subtracted? When you're looking at a fraction, you're looking at its numerator and its denominator to see if if it's a perfect square. Does that make sense? If the numerator is a perfect square and the denominator is a perfect square, then the fraction is a perfect square.
Yeah, 'cause 1/2 times 1
Yes,
half
we get it.
1/4.
Exactly.
Is it like
So
1 fourth x plus 1 fourth x minus.
One half.
The
There we
square
go.
root is half. The square root is half. Yeah.
3. Because there's nothing that multiplies to give you 3, no, or 7, or 11, or 13, 19, 17, 18. Well, those are prime, but I'm saying 18 isn't prime, but it's not a perfect square. Yeah,
9.
9 is a perfect square, 3 times 3. That's not a perfect square. All right, last one out loud. Are they perfect squares? Yes. And is it being subtracted? Yes. What is my factor? Oh, good job. There y'all go. Grab my plus. How do we feel about difference of 2 squared? All right. So the conclusion, if A and C are perfect squares, right?
Yes.
If those 2 are perfect squares and they're being subtracted, right? The key thing is they have to be subtracted. All you're doing is taking the square root and adding and subtracting the fact. Yes, there's only can have 2 terms. Yes. All right, 90 seconds. Get her done. Your turn on your own, quietly by yourself. Quietly by yourself. 90 seconds.
You're an elementary student. What was that?
30 seconds down.
You're a- Oh, shoot, I almost wrote down the wrong one. Oh, no.
If you need me as I'm walking around, please let me know. All right,
11.
check with your table.
Yeah, that's.
Compare your answers with your table. Compare your answers with your table. You got 15 seconds left. Good. All right, so we got x minus 3, x plus 3. We got here. And then we have,
Oh, it's 8.
and then we have, and
AK plus 8.
so we can do difference of 2 squares. All right, perfect. No, we can't. We can't. All right, on to our next special.